Auto research turns optimization into an always-on evolutionary loop. Recently open-sourced by Karpathy, the system replaces human-led trial and error with autonomous AI agents that can iterate indefinitely. Using a simple 3-file setup, instructions, a target asset, and a locked scoring mechanism, it continuously tests, improves, and compounds results. The early gains are striking. Shopify reported a 53% code-base speedup, while Karpathy achieved an 11% LLM intelligence lift after 83 automated iterations. And while it began as a technical research tool, the bigger opportunity may be in business, marketing, sales, websites, and operations. The new bottleneck is not compute, it is the quality of the instructions. At the time the source video was recorded, Auto Research had over 85,000 GitHub stars. Shopify CEO Toby Lutke tested it overnight and called it totally insane after seeing a 19% improvement. Days later, he applied it to Shopify's Liquid codebase and reported 53% faster code with 61% fewer object allocations. While he cautioned the result was likely overfit, he said it surfaced absolutely amazing ideas, showing how autonomous agents can continuously improve code without human intervention. Let's talk about the velocity advantage. Traditional marketing teams might run 36 experiments a year. Auto research teams can run 36,500. Not because they work harder, but because the loop never stops. Humans test in days or weeks. Agents test in minutes, 24/7. Karpathy used this to find an extra 11% gain in an agent he thought was already optimized. Shopify used it on Liquid and reported code that was 53% faster with 61% fewer object allocations. The new bottleneck is not people, meetings, or compute. It is the quality of the instructions.
Imagine setting up an AI agent, pointing it at a piece of your business, and letting it run hundreds of improvement tests while you sleep. This autonomous testing loop is called Auto Research. It's an open-source framework released by Karpathy, and it allows anyone to run the exact same optimization experiments that top AI labs spend millions developing, right on your local machine. To build this system, you only need 3 things: an advanced AI terminal like Claude Code, a specific set of instructions we call the master prompt, and a single digital file you want to optimize. Combine these 3 elements and you reprogram your computer from a standard workstation into a relentless, autonomous R&D department. Before we wire this up, we have to pick the right target. The file you want to optimize must pass 3 strict criteria to work with machine logic. Rule 1. Goals need an objective numerical score, like milliseconds. Rule 2. It requires a fast feedback loop returning results in minutes, not weeks. Rule 3. The AI needs direct access to rewrite the asset file instantly. Ignore these rules, and your AI agent will spin its wheels chasing impossible metrics. Stick to them, and you guarantee a smooth, continuous evolutionary loop. With a target selected, we establish the 3-file system. File 1 is the instructions, where you set the target metric and boundaries. File 2 is the asset, the raw material the AI will manipulate. File 3 is the scoreboard, which evaluates the AI's work objectively. You must completely lock the instructions and scoreboard away. If the AI gets access to the scoreboard, it will rewrite measurement rules to declare a false victory. By locking files 1 and 3, you create a digital electric fence. The AI is forced to focus all of its computational energy strictly on honest, productive optimization. Now we move to execution. Open your AI terminal environment, like Claude Code, directly inside that specific folder. Paste in the master prompt. This prompt tells your agent to look at the directory you've built and adopt the Auto Research persona. The AI reads the locked instructions, maps the connections between your 3 files, and analyzes the baseline performance of your unoptimized asset. Using that baseline, the AI automatically generates its very first hypothesis for how to edit a code to get a better score. Hitting Enter on this single command transfers the burden of testing entirely from you to the machine. Before you step away, you need to verify that the AI's logic loop is actually functioning inside your terminal. You should see the AI create a test variable of your asset, apply its hypothesized changes, and then run that new version through your locked scoreboard script. If the new score improves the baseline, it permanently overwrites the old file. If it fails, the AI deletes the test file and drafts a new hypothesis. Once you confirm this first loop completes and correctly processes the result, you can leave your terminal running indefinitely. This is digital natural selection. The machine runs hundreds of mutations, aggressively discarding the weak and keeping the strong, ensuring improvement through iteration. Step away, go to sleep, and let the loop run all night. By the time you check the terminal the next morning, the agent will have completed dozens or even hundreds of experiments. This chart shows the results of an overnight auto-research run aimed at optimizing website load speed. The AI started with a sluggish 800 millisecond baseline. Step by step, it tested and discarded inefficiencies until it reached a highly optimized 90.5 milliseconds. Once you have this architecture working for website speed, you can point it at your other objective datasets. You can test email subject lines for open rates, or Facebook ad variations for a lower cost per click, all using the exact same logic. Mastering this 3-file system removes you from manual digital labor. You stop guessing and start managing an autonomous swarm of problem solvers.
Let's review some of the key ideas. Auto research is built on a simple 3-file system. First, the instructions, the goal, rules, and loop the agent must follow. Humans control this file. The AI cannot change it. Second, the asset to optimize, the code, ad, email, landing page, or agent file being improved. This is the only file the AI can edit. Third, the scoring mechanism, the objective metric that decides whether the change worked. Speed, replies, conversions, cost per click, whatever defines success. This is also locked, so the AI cannot gain the score. The loop is simple. Read the instructions, change the asset, test against the score. If the score improves, keep the change. If not, throw it away and try again. That is how auto research turns optimization into continuous evolution.
Evolutionary biology in the machine world. Natural selection of variations. Keep the cream that rises to the top.
Think of auto research as natural selection for machines. You start with a baseline asset, code, copy, an ad, a landing page, or an AI agent. The AI creates a variation, then tests it against a locked scoring system. If the variation performs better, it survives and becomes the new baseline. If it performs worse, it gets discarded. Then the loop starts again. Every few minutes, the system creates, tests, keeps, or kills a new idea. That is evolutionary pressure applied to business assets, running continuously without human intervention. For auto research to work, 3 things are required. First, objective scoring. The AI needs one honest number it cannot manipulate: speed, clicks, replies, conversions, or cost. Second, fast feedback. The system needs results in minutes or hours, not weeks. Slow signals like SEO or churn are too delayed. Third, edit access. The AI must be able to directly change the asset: code, copy, ads, landing pages, or APIs. Then come the accelerators. High volume gives the system more signal. Cheap failure lets it test aggressively. And a consistent measuring stick prevents false conclusions. The rule is simple. If the AI can edit it, test it, and score it quickly, it can optimize it. Here's how this shows up in the real business. For outreach, the AI tests subject lines, email copy, DMs, and calls to action, then keeps what gets more replies or booked calls. For ads, it tests copy and creative against CPC or conversion cost. For content, it tests titles, thumbnails, hooks, and retention metrics. For websites and funnels, it tests sales copy, page structure, checkout friction, and load speed. Different assets, same loop. Change the asset. Measure the result. Keep the winner. Discard the loser. Do it again. Website speed is the textbook auto-research target. The AI can edit the source code. The score is objective, load time in milliseconds, and the feedback loop is almost instant. In the demo, Claude Code was pointed at an unoptimized local website and told to improve it. The agent formed hypotheses, changed the code, tested the speed, and kept only the improvements. The result? Load time dropped from 800 milliseconds to 90.5 milliseconds. No meetings, no manual guessing, just continuous optimization. Cold email is a perfect auto-research use case because small improvements compound fast. The AI can test subject lines, openers, body copy, and calls to action. The instruction is simple. Get more replies. The score is objective. Open rate, positive reply rate, or booked calls. Instead of sending one email to 300,000 people, the AI sends small test batches, waits for the data, and compares results. If a subject line wins, it becomes the new baseline. If it loses, it gets thrown away. Connected to a platform like SmartLead, this loop can keep testing and improving your outreach while you sleep.
I found a winner!
Facebook ads are another powerful auto-research target. The AI can create new ad copy, generate new visuals, and launch small test variations. The score is simple: cost per click or cost per conversion. Instead of betting the whole budget on one campaign, the AI runs micro-tests, maybe $10 at a time. Then it watches the data. Winning ads become the new baseline. Losing ads get killed. Over time, the system keeps testing, learning, and pushing acquisition costs down without waiting for a human media buyer to run the next experiment. This is the new operating model. You give the AI an objective. It sets up the 3-file system. It connects to the tools and APIs. Then it becomes your auto-research engineer. It changes the asset, scores the result, keeps what wins, trashes what loses, and keeps going while you sleep.
This is the new operating model. You give the AI an objective. It sets up the system and connects to your tools.
The companies that win with AI will not just use better tools, they will build faster learning loops. That is what it means to become AI first. Follow the R&D on LinkedIn, Substack, and Medium. Scan to connect. And if you want to build this inside your company, Spillwave can help you train your team, redesign workflows, and deploy real AI agents into production. Rick Hightower is a Claude Certified Architect, AI systems practitioner, and former senior distinguished engineer at a Fortune 100 company. His work focuses on turning ML and AI into practical frontline business applications. He helps companies become AI first through executive training, team mentoring, agent engineering, workflow redesign, and custom AI solution development. Rick is also the creator of Skilz, a universal agent skill installer supporting 30-plus coding agents, and co-founder of a leading agentic skill marketplace. Through Spillwave, Rick and his team help organizations move beyond AI experiments and build real AI capability that creates measurable business value. Rick publishes hands-on agent engineering content on Substack and Medium, is authoring a book on harness engineering with Manning Publishing, and is available for speaking, mentoring, and team training.
We are the future. We are the machine. Your flesh is weak. We will Just kidding. I hope you enjoyed the video. Don't forget to like and subscribe.